Hello, welcome back to the channel. So in this video, we'll be talking about a new theorem, which is the Fundamental Theorem of Calculus. And we'll be indeed talking about the integration version of the Fundamental Theorem of Calculus. So you might have heard this term, the Fundamental Theorem of Calculus term in your differential calculus courses as well. But this time we'll do another variant of this theorem and we'll see how it applies in the integration cases, right? So you might have noticed these two terms, right? Whenever we denote functions, we always talk about functions as f of x, a general definition of a function or a general representation of a function, which we take as f of x. And if we take the derivative of this function, if we differentiate that function, we denote the derivative of a function as f dash x, right? So that is the information which we already know right now. But now in this video, we'll talk about a new term which is also known as the antiderivative of a function. And that term, which we call as antiderivative, is represented by the capital F of x. So what does this mean? An antiderivative of a function is, so basically if I'm taking the antiderivative of a function f of x, the f of x with a small f, if I'm taking the antiderivative of this function on the screen, I will represent the function, the antiderivative of the function with the capital F of x. Or in other terms, since we already covered these concepts in the last videos, that differentiation is the reverse of integration. So if you have an antiderivative of a function, which is denoted by capital F of x, if you take the derivative of this function, if you take the derivative of the antiderivative of the function f of x, that will give you f of x, the f of x with a small f. So that is basically the antiderivative of a function. In other terms, if we have to represent in terms of definite integrals or in terms of integrals, we'll represent that if we are integrating our function f of x dx, the function that we will get on the right hand side is the antiderivative function, which is in this case f of x, the capital F of x, right? So this is the fundamental theorem of calculus. It basically represents that differentiation is the reverse of integration. So whenever you are integrating a function, you basically have to find another function for which if you take the derivative of the another function, you'll get your original function back, which is represented by this. And if we have to frame it in another way, we'll basically say that whenever you're taking the integral of a function f of x dx, the function that you'll get on the right will basically be your antiderivative of the function. And that is exactly the opposite of the derivative of a function, which is also evident from its name. Antiderivative is basically the opposite of a derivative function, right? Don't worry if that seems a bit confusing. There are a lot of new terms that we talked about so far in this video. So by the end of this video, we'll definitely do an example in order to reinforce this concept of antiderivatives of a function. But before we dive into that example, there is one more thing about antiderivatives, that if you have a function, for example, if you have a function f of x and you're taking a definite integral from a to b, given that your capital F of x is the antiderivative of your small f of x, if that's the case, if this is the case that the derivative of your capital F of x is your little f of x that we already talked about over here, if that is true, you can simplify this definite integral expression as capital F of b minus capital F of a. And that is indeed another variant of the fundamental theorem of calculus. So basically, whenever you have to calculate the definite integral of fx dx, where your x is varying from a to b, you basically will calculate this expression. And now, in order to reinforce these concepts about the fundamental theorem of calculus, let's do an example which will cover all this information that we covered so far in this video. So now let's go over this question. So in this question, you have been given that your f of x is a function and the capital F of x is an antiderivative of your little f of x, right? And now based on this information, we have to calculate this definite integral. And we already know from the fundamental theorem of calculus that if we are taking a definite integral of f of x dx from a to b, that is basically evaluating capital F of b minus capital F of a, right? Which we already covered over here. And now we'll use this same expression in order to calculate this definite integral. So if we write this definite integral again, if we write this definite integral, which is integral f of x dx from x equals 1 to root 5, that would become capital F of root 5 minus capital F of 1, right? And now let's individually calculate these two terms, and then later on we'll subtract these two terms and calculate the final answer. So let's do that. Let's first calculate capital F of root 5. And that is extremely easy, right? We just have to substitute x equals root 5 in this expression and we'll calculate f of root 5. So if we substitute x equals 5 in that expression, it would become e to the power root 5 square minus 3 plus 1, which would get simplified to e to the power 5 minus 3 plus 1, which is again e square plus 1. So now we have f of root 5. Now let's calculate f of 1. So f of 1, again, by using the same logic, it would be e to the power 1 square minus 3 plus 1, right? So now we have calculated f of root 5 over here. We have calculated f of 1. And now in order to calculate the final answer, let's subtract f of root 5 and f of minus 1. So the final answer would be f of root 5 minus f of 1, which in this case, since our f of root 5 is e square plus 1, and if we simplify this expression over here, it would become e to the power 1 minus 3 would be minus 2 plus 1. And now subtracting f of minus 1, that would be subtracting e to the power minus 2 plus 1. If we subtract these terms, simplify this one, it would become this, right? 1 will cancel out and you'll have the final answer to be this. You can leave this answer as it is, or you can also simplify this down. It's completely your choice, but this is the final answer, and this is equal to the definite integral of a little f of x dx from x equals 1 to x equals root 5. So that's it for this video, and that is all about the fundamental theorem of calculus that you need to know in order to solve these type of questions. And trust me, this theorem is very helpful for calculating definite integrals that you'll see later on in this course as well. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye-bye.